I'm going to go ahead and expand that. All right, so air pollution. If you're taking a course on weather and climate, of course, air pollution has to come up. It's one of the big reasons why. Well, weather and air pollution are linked. Air pollutants can affect weather and climate. Of course, carbon dioxide in the air, excess carbon dioxide in the air influences the temperature of the earth. And also particulates can also affect things like visibility. And then the other way around too. Weather influences pollution. What conditions influence the dilution and dispersal of pollutants? Well, you've learned up to this point the importance of temperature inversions on convection and precipitation. Well, it's also a very important reason why pollution doesn't get mixed out if there's a temperature inversion, particularly a surface temperature inversion. And also things like rain tends to wash out pollution, and winds as well. What is the wind speed? If you have stagnant winds, the pollution will build up. Windy areas can disperse their pollutants. All right, so you have some views of some very polluted cities in China and India. Hardly see in front of yourselves. Well, what's the source of primary pollutants? Primary pollutants meaning pollutants that pollute the air as soon as they're emitted are termed primary. All right, you have natural and human accentuated types of pollution too. Natural pollution, let's see, things like volcanoes, obviously, they put a lot of soot and dust in the air. Breaking seas puts sea spray in the air, and that can make coastal areas a little more cloudy, foggy. Trees cause air pollution. Well, pollen, we go through pollen season every year here. You know what that's like. Well, that's air pollution. That's the trees doing it. And also chemicals such as terpenes are also a volatile organic. That's also a pollution. And these other things like wildfires are natural, but they get accentuated by people by starting more wildfires. Blowing dust is certainly perfectly natural, but when we plow up fields that shouldn't be plowed, that accentuates that. Bacteria and viruses are also floating around in the troposphere as well, and that's also accentuated by humans. Those that are created by humans, well, there's this list, like combustion, chemical processes, nuclear weapons, all right, that can pollute the air. All the roasting, heating, and refining, burning coal, big part of that. All the mining, quarrying, also puts a lot of particulates in the air, chemicals in the air. Also farming too. Do farms pollute? I thought farms were natural. Well, again, with farms certainly can put not only blowing dust in the air, chemicals in the air as well. All these things are created by humans. Right, and here's some examples of those. Pollen, sure. The Secretary of the Interior under Ronald Reagan's administration, his name was James Watt, and he sometimes put his foot in his mouth, and especially newspapers were looking for ways to misquote him. And one of the things that he said was that trees cause air pollution. Now, how can you have the Secretary of the Interior that believes that trees cause air pollution? Trees absorb pollution. Trees make us feel cooler. Trees are natural. How could trees cause air pollution? Well, they certainly do. If not the pollens, then certainly the terpenes and chemicals. You know, plants can be very competitive. They secrete and give off things that the other living things, plants, other trees don't like. All right, well, we'll take a look at that. Volatile organic compounds. These go into the atmosphere. They interact with sunlight, and they produce ozone, secondary pollutant we'll have to talk about later. And so, for example, here, Western Carolina, see the smoky haze there. Some of that's fog, but some of that is ozone gas created by the trees, is part of that. All right. So trees can cause air pollution. Also, when they're burning, they cause air pollution too. But for the most part, though, we like trees as ways to help us against air pollution. Trees also absorb air pollution. They look nice. All right, make us feel more comfortable as well. So certainly all these things are natural. Now, 2 years ago, oh no, 3 years ago now, it was in the news a lot. There were the Canadian wildfires that were making it hard to see in New York City. This was hard to believe, that the fires could be that intense and the smoke could blow all the way to New York and still be a haze that you couldn't see through. All right, it's well documented. There's a YouTube link. Watch it when you get a chance. Right, and then, well, obviously volcanoes produce a lot of particulates. That's beside getting out of the way of the lava at the surface. They put a lot of particles in the air, gases, and so forth. Some of these will combine with natural elements in the air, water vapor and oxygen, and form a type of smog. Ozone, sulfur dioxide smog that's created by a volcano. And here, you think you want to go to Hawaii, especially the Big Island. It's so natural there. Well, volcanic eruptions do put smog in the air. All right. Well, this is a good example of accentuated by human activities. Out in the Great Plains, farmers were plowing land that they should not have. And it came about, you may have even heard about it in history class. It was the Dust Bowl decade of the 1930s, because in the decades previous to that, around the time of the turn of the century, late 1800s and early 1900s, there was a big demand for wheat in Europe, and also it was a rainier period. So you had these nice flat plains for growing grains, and they were doing that. But then the climate turned back to being natural. It's a semi-arid environment, dried up, dust storms coming through, covering everything. This is well illustrated in the PBS Ken Burns documentary, the Dust Bowl, and also the movie Interstellar. They used a lot of the scenes from that in that. Okay, so exacerbated by human activities. Well, see, is pollution bad? Pollution means that you have jobs. It means you have factories are polluting the air. Yeah, but that means that there's factories. It means that there's going to be workers in those factories. It might be a tough place to live in such a polluted environment, but for most of the industrial revolution of the United States through history, pollution was accepted as a byproduct of having the industries and the railroad and so forth. So, quote Mr. Burns. And then the poet William Blake described the factories of England in the poem. He mentions the dark satanic mills. So even then there was some concern of pollution in the environment and questioning, is it worth it to do these things? Environmental ethic. All right, what else? Here the pie chart shows the percentage of the different primary pollutants. What's the single greatest air pollution by weight? Right, if you're going to weigh them, it's carbon monoxide. You wouldn't think that, right? Carbon monoxide, it's a gas. Doesn't weigh anything. Yeah, it adds up in the air. So that's a lot of weight. Nitrogen oxides from your tailpipe, that's a lot. Sulfur dioxides that come from burning coal, volatile organics, these are hydrocarbons. Whenever you're dealing with anything hydrocarbon, gasoline, or pine trees, produce a little bit of that. And then particulates. Oh, the particulates. All the dust particles, smoke particles. Smoke is not a gas. You see smoke, but do you see the individual particles? What it is, it's a lot of particles floating around the air, and then collectively you see them as smoke. All right, and then what's the answer to the question, what source is responsible for most pollution? If you wanted to break it down this way, it would be transportation accounts for the greatest amount of pollution. Yes, but well, you have to have a car, right? You live here, you have to have a car. You have to have some type of transportation. You have to burn gasoline. But if it was carbon monoxide by weight, the one that probably kills us the most out in out in the environment, commuting to work, if you live in a city especially, it's ground level ozone or tropospheric ozone, and also the little particles floating around too are the ones that pose the greatest threat to human health. All right, now this is a preview of the one part of the weather report. Sometimes they have the air quality index where it's green if it's a good day, and then red if it's an unhealthy day, and even turning shades of purple if it gets worse than that. When that's the case, whenever you see that as part of a weather report, it's probably ground level ozone, explaining most of that in a city. Okay, well, I've been saying primary and secondary air pollutants. Primary doesn't mean the most important. A lot of times when you discuss factors, well, the primary one, well, here it doesn't mean the most important. What it means is first. It's the first to pollute the air. And that primary pollutants pollute the air as soon as they're emitted. So, for example, carbon monoxide from car exhaust is a primary pollutant. Secondary pollutants doesn't mean that they're less important. Well, they're secondary. Now, secondary means that there's another step. Secondary pollutants are created in the atmosphere when you have some primary pollutants and other primary pollutants get together, or some of the primary pollutants and natural air components like oxygen or water vapor combine together and make a new pollutant. So that's a secondary pollutant. So for example, the photochemical version of smog is the classic secondary pollutant. Acid rain would be another one of the secondary pollutants because it forms in the atmosphere. Okay, here's a list of primary pollutants, meaning that they pollute the air as soon as they're emitted. Particulates, sulfur dioxide, quick, what's the source? Usually from burning coal. Electrical generation explains a lot of that, so utilities. Nitrogen oxides, that's from your tailpipe. So transportation accounts for that. Sometimes NO, sometimes NO3. Volatile organic compounds, these are hydrocarbons. You get a whiff of that when you pump gas. You can say, oh, I smell some hydrocarbons. Carbon monoxide, it's created by incomplete combustion. It's a pollutant right away. And lead, that's from sources like smelting. You still might put some lead in the air, but it used to be in gasoline. And that's one of the great advantages your generation has. Your whole lifetime, there was unleaded gas. It was a lot worse. Leaded gasoline is probably giving people in cities brain damage. All right, that's another story for later. But that's a pretty important one. All right, pollutes the air. Well, particulates. What do you mean? There's all kinds of particulates. How big are they? This is one. Uh, the PM 2.5. That's a fine particulate matter. And then also something that's a little larger, but it's also part of pollution standards, is PM10. That means 10 micrometers. So fine particulates less than 2.5 micrometers. Do particulates kill you? Well, if you're breathing in particulates, it's not good. It might not be the particulates that kill you, but probably shortens lifetime. So on average, if you live in one of the more heavily polluted cities like Los Angeles, it probably decreases your lifetime a couple years. Yeah, you can't say, well, was it the pollution that killed them? No, it was emphysema that killed them, but pollution sure didn't help. So on average, it shortens our lives by about 2 years. That's just from particulates. I included this slide in the lecture notes. It's not in the book, but a comparable size of these particles. Where's PM 2.5, PM10 in relation to these larger particles, right? Flu virus, 20 nanometers. That would fit through those masks that we had to wear for several years. The mask didn't stop the virus. Well, it stopped the droplets. You know, the droplet is larger than that, but the actual virus itself was smaller than the mask we were wearing. Okay, that's another story. That's relative sizes. A lot of people wear fine particle masks in large cities outside of the United States. Oh yeah, and we didn't do a lot with the Null School website this year. You had other websites to investigate, but on the Null School is a very good educational tool. It gets current conditions around the world. You can see where the waves are. You can look at different levels of the atmosphere, see where the jet streams is. And one of the things that it does is it shows you where there's a lot of particulates in the world. It would be good to spin that around. And where do you have a lot of particulates? Well, in some of the desert areas, you do, and also big industrial areas in China, a lot of particulates there. If I went to the site, swung the globe around, you'd compare to the United States, you'd have a lot less than areas that produce a lot of these. Yeah, you could choose what particle size you wanted to take a look at, as opposed to blowing sand. Is cigarette smoke a type of pollution? Well, there's a whole category of indoor air pollution. There are things in the building materials, chemicals that are floating around in the air, and the new car smell. Everybody loves the new car smell because you're driving a new car, but you're also getting toxic chemicals from that new car smell as well when you're breathing it in. Generally, the rule with particulates, if you can smell it, you're getting the particles of whatever it is that you're smelling. Okay, so cigarette smoke. And also one of the other things we're finding out is that secondhand smoke. So I was never a smoker, but I grew up around people that smoke like chimneys, so I might as well. All right, that's indoor air pollution. And also there's a whole category of air toxics. In the various chemicals that we use in everyday lives, and we're inventing new chemicals all the time. Many of those are airborne in their manufacture. Many of those get into the environments. There's an alphabet soup of various chemicals that are floating around. All right, this graph, I don't blame you if you find it hard to read. It shows you of the various types of energy, what's it used for. So, for example, 71% of petroleum is used in transportation, and 92% of the energy used in transportation is petroleum. I just shows some of these things. All right. Coal would also shows that coal is used a lot. There's a 91. That's going over their electrical power. Okay. That's difficult to look at. We won't spend too much time with that. Here's a simpler pie to look at. Sources of electrical energy in the United States. Well, we're still dependent on coal. In the past 5 years, we've been converting a lot from burning coal to burning gas. Well, gas is still a fossil fuel. If you burn coal, you're still putting out carbon dioxide, but natural gas burning doesn't have as many of the toxins and particulates that burning coal has. So coal burning is a major source of sulfur dioxide associated with acid rain. And well, we need energy. It takes money to make money. It takes energy to do anything, to have an economy. We're blessed with centuries worth of low quality, high sulfur coal. But dare we burn it because of the pollution problems that it causes, not only in the atmosphere, but from the mining of it and the surface waters as well. That's a major one. I had this slide in is pre-pandemic. This was the last thing that was in the news before the pandemic hit. These wildfires worldwide. So what does the plume show? Carbon monoxide associated with fires. Isn't that putting out carbon dioxide too? Yes, but carbon monoxide is also part of that. It's from incomplete combustion. So where do you have a lot of burning? I see a lot in those areas that either do a lot of burning of fossil fuels, or they do a lot of burning of the natural vegetation. Slash and burn agriculture is common in Africa, where trees are burnt down to clear the land. So that incomplete combustion produces carbon monoxide, not carbon dioxide. Well, both will smother you. Carbon dioxide will give you brain damage. All right. Oh, that's one of the ingredients in cigarette smoke. So whenever you see somebody drawing on a cigarette, yeah, they're getting their hit of carbon monoxide, amongst other things, killing the brain cells. All right. I won't imitate. All right. So the question is, and probably the microphone will pick it up if you answer. Which one of these are primary pollutants? And the hint is find the secondary pollutant. Well, okay, so which one is the secondary pollutant? It should jump out at you now. It's ground level ozone. Ozone is put together at the surface from other pollutants, volatile organics, nitrogen oxides in sunlight. So the other carbon dioxide is primary pollutant. Chlorofluorocarbons, but aren't those man-made? Yes, but they're still a primary pollutant. All right, methane from a lot of different sources of primary pollutant. All right, distinguish between, well, I say I've been talking about smog and photochemical smog. Sometimes they say classical smog, smoke and fog together, or just general urban air pollution. They looked at that in the video we looked at before class. Photochemical smog is something different. All right. London smog. Well, that was classic smog. Sometimes it's called smog classic, like Coca-Cola classic. Smog classic, classical smog, or London type smog from a buildup of water vapor and coal burning, sulfur dioxide in the air, producing this cloud. I can't tell, is this I think this is a black and white photograph. Either that or or there's a lot of carbon there. And then that one, there's a Bobby there. Let's see, he's holding a flame there in order to see. I expect Jack the Ripper to be somewhere in that alley, or the American Werewolf in London, or something like that, there in London. Well, what happened was there was a unusual high pressure cell that sat over England for a long time, and they burn a lot of coal. Back then, coal was used for home heating. Not so today. Do you know anybody that burns coal? Everybody's connected to Piedmont Natural Gas, like right? People used to burn coal for home heating. Yeah, the United States used to burn coal. To tell you how old I am, I had a neighbor in my neighborhood, old lady. She got a coal delivery every couple of months. And there was a coal chute, took it down her face. She burned coal. We didn't at our house. We were modern. But there was still a house in the neighborhood that burned coal. That was in the 70s. All right, so this was common. So it had to pass a lot of laws against burning coal and finding alternatives. So that time, sulfur dioxide, smoke, produced a lot of deaths. So that's classic London type smog. Photochemical smog, well, it's a secondary air pollutant. The chemical trail of this is quite complicated. I can direct you to articles about this. It basically comes down to this. Stuff that comes out of your tailpipe, nitrogen oxides, as well as the volatile organic compounds that are in the air, recombine to make an alphabet soup of chemicals. The output, the most dangerous part of it is this one. O3. Remember ozone from chapter 1. The ozone layer in the upper atmosphere protects life. Well, when it's generated, O3 and then some other alphabet soup as well. O3 is what I call the business end of it. It's the worst part of ground level ozone. So that's the chemical that attacks living tissues. All right, that's the worst part of a bad air pollution episode. All right, there's that. Okay, one of the questions on the list is, what time of day is ozone formation at its peak, and when is ozone season? Well, it's photochemical. So you have to have the VOC and the NOx. The sunlight is the catalyst of that. Strong ultraviolet light. So it's that time of day when the UV is the strongest, and it's that time of year when the UV is strongest, will produce the most ground level ozone. So ozone is bad for you. You don't want to breathe it in. Well, then why are we concerned with saving the ozone layer? Well, that's because in the upper atmosphere, the natural ozone is a good thing because it shields us from the harmful rays of the sun. The harmful shortwave waves of the sun are absorbed by the ozone layer. So it's good to protect the ozone layer and not manufacture ozone depleting chemicals. At the surface, though, it's a pollutant, and you would say it's a dangerous pollutant given the condition of many cities. All right, so ozone. This is going back. This is actually all from chapter 1. Remember the ozone layer? It's good that we have an ozone layer. It's bad when it's in the lower atmosphere. Right. That's my quote from Frankenstein. If this was the fall semester, it would be right at Halloween. Okay. And then also VOG is a secondary air pollutant. When the volcanoes put out their prerequisites for smog, and then they're put together in the atmosphere. It's VOG. Good for you. See, I was living when I was a little kid, junior high and high school. This is the peak of all this stuff. Wasn't until the Clean Air Act came in starting in 1970. The trend has been down and down and down. As far as the sulfur dioxide, we're washing the coal and scrubbing the coal, smokestack, scrub it up. That's in the decline. Pollution control devices on cars also bringing down the nitrogen oxides. And then hydrocarbons, along with those other transportation-related ones, also on the way down. Right. So, especially signed in 1970 was a big year. President Nixon, the EPA was created, setting standards. What happens if somebody breaks the standard? Well, there's standards. There's things we do to try to modify that. So many more pollution controls on transportation and industry. People started complaining about a catalytic converter. It's slowing down my car. Or unleaded gasoline. It's making my car knock. Yeah. Lead. Yeah, you don't know how good you got it. Lead was poisoning the population. We're burning lead. You see, you probably have never seen leaded gasoline at a gas. I don't think you did. It used to be regular and unleaded. Now, regular is unleaded. Okay. No, you're not going to buy leaded gasoline. All right, you got the lead out. Yeah, even then, what are these years? Started in 1980. Yeah, a lot of it is already cut out. Mr. PB, reducing it quite a bit, and it's a good thing. It saved problems with your brain cells. They're testing kids in urban areas at high levels of lead. Some were saying it was because they were eating the lead-based paint peeling off the walls that tasted sweet. And kids did do that and got lead poisoning that way. Or there's lead in the old pipes in the older places in the city. But it's also the big part of it was lead was floating around in the air poisoning us. So somebody had to pass a law against that. Lead. It's not cute effects, it's acute effects. That's life-threatening, right? In that there was a pollution episode and you breathed it in and it killed you. That's the acute effects. That's different than long-term effects. You're breathing in these hydrocarbons every day, and you're breathing in those particulates every day, and it deteriorated you over a number of years. Right, the standards. Well, rules are there to be broken, so the standards are often exceeded, mostly in the cities. That's what this graph shows. It shows that a lot of people live in cities, so a lot of people are exposed to tropospheric ozone and the other chemicals. All right, something here. The question is, what pollutant has not decreased? So by agreement, we've been able to bring down aggregate emissions quite a bit while our wealth has gone up. Yeah, we're a lot more wealthy now than we were in 1970. We got a lot of luxuries. A lot of the luxuries we have today. These were undreamed about when I was a kid. All right, so let me see. Energy consumption is still up there. The population's gone up. You know what really hasn't decreased too much is carbon dioxide. This carbon dioxide goes along with fossil fuel use for energy. And you need to have energy in order to have the economy. So it's kind of flat. I'd say carbon dioxide in relation to the other ones. Nitrogen oxides, way down. Sulfur dioxide, way down. Particulates, way down. Lead, way, way down. But carbon dioxide, kind of flat. Right? Yeah, kind of flat. But everything else, SO2, VOCs, NOx, down, down. Air quality index, all right, index part of the weather report. EPA also publishes this on their website as well. So it's an index, good to unhealthy, meaning that on certain days, you're not supposed to breathe the air. Okay, well, what does that mean? Well, it means you should be in a climate-controlled area. People with emphysema, or the babies, or the very old, that are in sensitive groups. It's better to keep them in some type of climate-controlled environment, because if your city is so smoggy, then that's unhealthy. All right, our weather report. I like this one. Shanghai, right? They use an anime character graphic to put on the bus to show what the air pollution is like in Shanghai, which is fairly coastal. So you can mix some air out, right? So excellent. She's smiling, and then she gets a little bit of frown. And then if it's Beijing level of pollution, you're dead. All right, because Beijing is extremely polluted. Okay, air quality. Here to wrap this up. Air quality is determined by two things: the source type and amount, meaning that, well, what kind of pollution it is, how much it is, how many people are driving, the population. So the source type and amount versus the capacity of the environment to disperse it. If you live in a place that has a lot of temperature inversions, a lot of the sunny places, you want to live in a sunny climate, right? Sunny days, several days on end. You know what's building up? Air pollution at the surface. It's not mixing out. That's one of the good things about rain. I have a lot of cyclones zipping through. It mixes out the pollution. Okay? All these things. Sunshine, photochemical oxidants, rain, wash it out. Higher temperatures speed up the chemical reactions for secondary pollutants. All these things. You want to dilute it out. So the stability of the air, meaning not having an inversion, unstable atmosphere, a deep mixing depth, those are all terms. Right? The old adage in meteorology is this: the solution to pollution is dilution. That's the trick, is to get it diluted. You want to have fast winds, will disperse the pollution better. Mixing depth, that's one of the terms in the book. You probably have a quiz question about it. It's in there. It's depth. But isn't it height? No. Which way are you looking? All right, so you're looking from heaven down, and it's the depth. Looking at the surface up. That's the height. That's how far up convection is. So you have convection, it mixes out. And if you have an inversion layer trapping it, that's not good. All right, likely you have some type of question about inversions. Okay, here I've got, say, 10 after in the last 5 minutes. This would be a good going to put together question to put on my list. I think in the 1990s, it was very popular to have these children's books called Where's Waldo? And you had to find Waldo in a crowd of people. Did any of you ever seen it? Okay. Well, it's kind of like this, only Waldo is found here. We know where Waldo is. And there's a diagram in the background. So Waldo is asking, can you find all of the inversions in that picture? Can you describe the inversions? Now, Los Angeles is one of the most polluted cities in the country, if not the world. Mexico City gives it a pretty good run. But Los Angeles is very polluted. It's in a valley. Even the native peoples of that area, notice very often there would be a haze hanging over the valley. Just after wildfires, there'd be a haze. Pollution didn't mix out. That's for a lot of reasons. Los Angeles is a valley. It's like the Hollywood Bowl, right? Not the Hollywood Bowl, but it's kind of like a bowl surrounded by mountains. The westerly winds go from west to east, are kind of blocked by those mountains. So there's not a free flow of air from west to east. Plus you have a big population. No one drives in LA. You have to have a car. You have a huge source of tens of millions of people and a big source of air pollution. Could they have had good public transportation built because of the environmental problems in that area? Yes, but the oil companies bought up all the public transportation and let them decay, so no one used them. All right, you can read about that in history book. All right, so you have that. So it's a big source of pollution. What are some of the things what are some of the inversions? Yeah, grab one when it goes by here in the last couple of minutes. Cold water current. How would that create an inversion? California current's a cold water current. Stabilizes the air above it. So that comes inland, you've got cold under warm. That's an inversion. What's another one? Cold air drainage from mountains. Okay, so at night, cold air goes down slope by its own weight. So you have a layer of cold underneath warm. That's another inversion. Clear skies, radiated cold air. Oh yeah, it's sunny in LA. It's sunny in the daytime. At night, there's no clouds to trap heat in. Surface cools off, chills the air at the surface. Another inversion. Are there more? There's probably more that you could come up with too. The subtropical high pressure zone. Los Angeles is just at that latitude. It's on the business end of the subtropical high, sinking air. So not only have the surface inversions, you also have the upper air inversions as well. So you have inversions all over the place in Los Angeles and other areas with similar climate. All right. Yeah, inversions. You don't want to have inversions. Acid rain. I probably should say one more thing about acid rain. Rain is naturally acids, but the way it works, sulfur dioxide from burning coal, nitrogen oxide from our tailpipes go up to the atmosphere. SO2 mixes with H2O, becomes a weak solution of H2SO4 sulfuric acid that precipitates out downwind. And also nitric acids precipitate downwind as well. So it's a regional problem. You have the source in one area, and then you have the victims in the other area. Is acid rain a human health issue? No. Acid rain's not going to dissolve you. Sulfur dioxide will kill you, though. Don't breathe in sulfur dioxide directly from the smokestack. Yeah, that's bad for you. Sulfur dioxide is primary pollutant. Acid rain, that's an acidified environment. That's an environmental problem, not a human health problem. All right, looks like it's quarter after. Okay, next week, climate change. Make sure you do your third attempt at the quiz by midnight tonight.